Alright, I need to show that t is 1 to 1 if and only if the kernel of t is 0 element of w, where t is a linear transformation. And one key thing is that this is an if and only if statement. That means that these two things happen at the exact same time. It can't be that it's 1 to 1 and the kernel's not equal to 0, and it can't be that the kernel is equal to 0 and t is not 1 to 1. These are really synonyms in some sense if you have a linear transformation. So this is really nice. Once you have this result, it's really nice, because when you know this is true, you know that t is 1 to 1. Whenever you know t is 1 to 1, this is true. On the other hand, that means that you have twice as much work when you're proving it. So the way we often denote this is we're going to prove this in two directions. We're going to prove left to right, where first we're going to suppose t is 1 to 1. And then we're going to do, I hope I'm giving myself enough space here, the other direction, where we're going to suppose that the kernel of t is equal to the 0 element of w. So I'm going to suppose that t is 1 to 1, and I'm going to show that the kernel has to be just the 0 element. And then I'm going to suppose that the kernel is the 0 element and show it's 1 to 1. So I'm going to suppose that t is 1 to 1. Then for each output, there is at most one input. Since t of the 0 vector of v is equal to the 0 vector of w, we know this from before, the 0 vector of v is the only input of v that results in an output of 0w, which means also this is a typo, and this should be pretty clear. The kernel lives in the domain, so you can't have 0w. So this would has to be 0v, and your sheet's going to be fixed for that. So it should be 0v. The kernel of t is equal to just the set containing the 0 element of v, not w, but v, which we often write just as 0v. And why is that? 1 to 1 means that for every output, there's at most one input. But we have, right, the kernel means that you want to get 0w as an output. And we know that we have one input that does. If it were not 1 to 1, we might have multiple ones. But since it is, this can be the only one. So if it's 1 to 1, that means that 0v is the only possible input that gives you a 0 in the w, linear space. So that's 1/2 done. Now I'm going to assume the opposite. I'm going to assume that the kernel is 0w, and kernel is 0v, sorry. And I'm going to show that's 1 to 1. So the way I'm going to do that, this is completely standard for showing that things are 1 to 1. I'm going to assume that a and b are elements of v such that t of a equals t of b. In other words, I'm going to suppose I have two inputs such that the outputs, t of a and t of b, are the same. I'm going to show that a and b just have to be two different names for the same thing. The way I'll do that is I'm going to say, well, t of a minus t of b has to equal the 0 element of w then, because I can just subtract from both sides. But t is a linear transformation. That means that t of a minus t of b is equal to t of a minus b. So when I plug a minus b in, I get the 0 element of w. That means by definition that a minus b belongs to the kernel of t. But I'm assuming that the kernel is equal to only the 0 vector of v. So the only option is that a minus b has to equal 0 vector of v. So a has to be equal to b by adding. So from here I conclude that t is 1 to 1. So why is t 1 to 1? Because I assume that I had two inputs, two names for inputs anyway, that give the same output. Well, if this happens, that means that, the two inputs were actually the same. which means that you can never have two different inputs giving the same output. That means that t is 1 to 1. So up here I showed that if it's 1 to 1, then you get the kernel is just 0v, and if the kernel is 0v, then you get this 1 to 1. So I proved this result. So a really slick way now of showing that something's 1 to 1 for if you have linear transformation. This is not true of every function everywhere, but if you have linear transformation, if you can just show that the only way that you get the zero element of w is that you plug in the zero element of this should be a v. In other words, the kernel is 0v. That means it's 1 to 1 automatically. We're done.